Exploring action for clarity and precision. This topic, number line, belongs to college algebra. It's very simple. Just we have to put in the right order the numbers, some concepts, some ideas. We are going to review some background we need to know or remember for order number or line, or exploring some axioms, some rules, some laws from mathematics. Okay, we have two problems right here. Like an example, the first one we have this set. For example, this set -3, -1, 0, 1, 3, and 5. So the main thing is we have to put in the right way in the number line. So for example, we have -3. Where is -3? -3 is right here. -3, and then -1. It's very simple, right? -1 is right here, and then 0, 0, 1, and then 3, and then positive 5, right? Simple. This is the first set. So the second set is a little bit more confused, like because we are using rational numbers or irrational numbers. It's from the this set is belong to the real numbers, all numbers, I mean. So we have to put it in the right place in the number line. For example, we have -2/3. What is -2/3? It's almost one whole negative number, right? Right here. So divide by 3 right here, the unit. So it's like also right here. Right here is -2/3. -2/3. And then we have 0 right here. 0. And then square root or 2. Square root number 2. How much is square root number 2? Is we have to find a number multiply by itself. It must be equals 2. It's, I mean, it's 2 times 2 is 4. So 1 times 1, or I mean, is between 1 square root number 2 is 1 point, almost and a half, right? 1 point something right here. So right here. Just I wanted you guys see the position of the each number. So right here is a square root, right? Number 2. Then we have square root number 5. Number 5 is for example, 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So here is 2. 2 times 2 is 4. 4 something is 2 something less than 2.5. It's also right here. So square root number 5 right here is square root number 5. Then we have pi. Pi is equals, remember that for geometry. So pi is 3.14 and 16. 3.14 and 16, so it's right here. 3 point something right here. 14 and 16 is pi is right here. Right? And then we have 4. Right? 4 exactly right here. 4. Right? So that's it. So this is the main thing. The object for today. Put in the right place the real numbers in the number line, right? But we have to remember some symbols too. So some symbols, for example, we have symbol and meaning. For example, symbol and meaning. That's very important. We have to remember for when you work with the number line, we use sometimes this sign. Remember this sign? This sign means less than or equal to, right? we have another sign, is this one, is greater than or equal to. Right? And then we have another signs. Well, sometimes we use, for example, this one. This means not less than. So not less than. We have this one, of course, not greater than. Let's just keep in mind to remember this kind of the concept, right? Then we have something else that we have to remember, inequalities. When use this topic, when you work with this topic, we have another main thing that you have to remember, inequality. Inequality. Or inequalities. Inequalities, right? So inequalities is like, for example, when you write 8 less than 10. That's an inequality. We have to know this kind of sign. That's what I wrote it before. Greater than, less than, or greater than, or equals, for example, right? So inequalities, we have use this sign, greater than, less than, or less or equals than, or greater or less and equals than, or equals the greater or equals than. For example, the sign that before I write it. Okay, inequalities. Another, for example, one main idea that I would like to write before to continue teaching this topic is this concept, number lines. For example, number lines are useful. And useful for when discussing real numbers. This is very important, keep in your minds. So a number line, this is background that you need to know, sets, okay, up a correspondence between the set of real numbers and set or set of points online. Points online. All right. So this you have to keep in your mind this great idea when you work in an order or numbers or number lines. So in another main thing, a good thing that you have to remember, for example, is another concept. The distance on the number line. So the number line from, look at this, from a number to 0 is called what? The absolute value, right? This is another good thing that we have to keep in your minds, some background for continue on this class or this topic. All right, good. So now do some exercise. I would like to make some exercise. For example, here after this concept, I would like to, you have for example here you have if we have negative 4, absolutely value negative 4, so the concept that before I write, so this, how much is a absolute value of negative 4? Absolute value of negative 4 is equals 4, right? So let's do another problem. We are looking for negative absolute value 8. So how much is this? This number, this negative absolute value of 8 is going to be negative 8, right? So let's write another problem with absolute value from when you work in ordinary numbers. In this topic, it's also we have to know how to solve these problems. You have this negative absolute value negative 2 is going to be, this is positive. What is the answer? When this is absolutely positive, absolute value from here, what is the answer? It's not times. It's not time. It's not time. So absolute value right here is going to be a negative 2, right? Negative 2, because you are looking for absolute negative. Absolute value inside here is doesn't matter. It's positive or negative is always gonna be a positive, the number, right? So it's gonna be a negative 2. Okay. Let's do some exercise. So the exercise. And this one, let me numerical order. So numerical order. All right. So let's do the first one, the first problem. Okay. Let's write these numbers. For example, negative 9, negative 2, whereas 3, and negative 4, and 8. Okay. This group, just write in order. So we have to write those numbers in order. So what is from less, the smaller one to greater one, from the smaller one to greater one. So in this case, to the left, the negative number to the left, the smaller one is going to be negative 9, right? And then we have negative 4, right? And then we're gonna have negative 2, and then whereas 3, and then 8, right? So numerical order. So that's it. Let's do another one. For example, let's write absolute value 8, okay, minus 9, absolute value 9, and this number, negative absolute value 6, from smaller to greater. Okay, what is the smaller one? This number is negative 9, right? It's going to be negative 9. This one is going to be negative 6, right? Negative 6. And then this absolute value negative 8 is going to be 8, positive. It's positive, it's going to be positive. Always the absolute value inside is positive, okay? So this is the solution. Let's do another one. It's a little bit more complicated, right? For example, square root number 8. So let's write, for example, negative 4 and negative 3. No, negative 2. And then let's write square root of 3. But negative, see, right? And then a square root, let's write positive, square root 6, and then a square root 8, and then 3, right? So what is the right way to write these numbers? So the smaller one. So we have we write right here -4, right? -4, right? We have -4 right here. So what is the next one? We have -2, right? -2. What is the next one? We have this negative. Oh, negative, of course. This negative square root. This one, negative square root. All negatives are smaller than positive numbers. Now, go to the positive numbers, right? The positive numbers. So after this one, we are going to have square root 3, square root 8, which is smaller. Oh, we have right twice the square root right here. So it's 3 right here. It's 3, only 3. So then square root number 6, right? And then square root number 8, right? And then 3. This is the greatest number, right? It's one way to order the numbers, these kind of ideas. So piece of cake for you guys, very, very simple, no? Okay, let's go and do another kind of exercise. So now we have to solve this couple problems, all right? Just put it include in this topic, in this class. One could be, for example, 3x minus 9. Remember when I told you or asked you about the symbols, right? The meanings of the symbols, the greater or equal or less or greater or equals, something like that. That's why. So these kind of problems you are gonna work in this topic too. You have this one. We have to find how much is x. So in this case, it's gonna be you have x right here less than 9. This is like times divided by 3. So the answer is going to be x less than 3, right? This is the answer. It's one problem. Let's go and solve another one. Let's write right here, for example, minus 2/3. So minus 2/3 are, see, greater or equals than 16. So look at this problem. That's something that we have to remember too from the algebra one. So it's coming from that long time ago. The all changed right here. So this is a dividing. This number is right now is divided right here. So you must change over there to dividing. So this is gonna be 2r greater than 16 times. So it's gonna be times right here times 3. So it's dividing here, the other side is going to multiply. So the answer is, if you simplify, it's going to be 48, right? Now, look at this. This is times. When you change the other side, you change to divide. So the answer is going to be right here. Look at this. It's going to be r. And then when this is negative, when you change this to the number is going to be negative here, change the coefficient to the other side, the symbol, this symbol is moving, it changes, moving right here. Moving, why? Because you change these two over here, 48, -2 right here. That's why. That's a rule. So now the answer here is going to be what? R less or equals than, what is the answer right here? -24, right? 24, right? This is the answer. All right, so that's it. So far, this topic about the order number of lines. So exploring some axioms for clarity and precision. We have some action too that we have to, for example, action or the order. Let me write right here some actions. We have some action right here. So action of order, for example, axiom of order. So action order. These could be transitive actions. Transitive action. What is that? So, for example, if A less than B, okay, and B less than C, then A is less than C. All right. So we have another rule, and this ordered number line that we have to keep in your mind is the other rule is clausura action. Clausura action. Okay, this one is, for example, if 8 is greater than 0 and B greater than 0 too, then look at this, then A plus B greater than 0. And so the conclusion, AB is going to be greater than 0, right? So this is another action, because we are talking exploring some action for clarity and precision. This is very, very important. This kind of rule that we have to keep in your minds. So on the other ones, the rules that I want to remember you is exactly one of the following. So the followings, like for example, this rule. Well, I want to write the numbers and then give you the rule after. This rule is called trigonometry. Dichotomy action. Okay, this one. So exactly one of the following. For example, you have here A equals B, right? And then for example, A less than B, or A greater than B. So this rule, this kind of action, it's called trigonometry action, right? So this is three kind the rules, 1, 2,